car has mass 800 kgs. The engine of a car generates a constant power of P kilowatts. As the car moves along a straight horizontal road, the resistance to the resistance is constant and is equals to R newtons. When the car speed is 14, acceleration is 1.4, and when the car speed is 25, acceleration is 0.33. Find P and R. This is a question on simultaneous equations. Let's try to form that equation first. There's a car with a mass of 800 kgs, which is moving in a certain direction. The engine of the car generates a constant power P kilowatts. So that means the forward force would be in terms of P, because the formula for power is driving force into speed. So the forward force or the driving force would be P upon V. Power over speed. So the driving force is power over speed, and the resistance to the motion is R. R here is resistance, not the normal contact force. Okay. So when this car speed is 14, the acceleration is 1.4. And when the car speed is 25, the acceleration is 0.33. Find the values of P and R. Okay. So let's use the formula forward minus backward is equals to mn. Okay. So forward force is going to be driving force minus backward force is going to be the resistance is equals to MA. Now for first case, it's going to be P is, well, we don't know P, instead we have A and we have V. Okay, so instead of driving force, I'm writing P over V minus R is equals to MA. Okay, now, it says P is in kilowatts. So I should write 1000 P over here. Okay, so this is actually 1000 P because P is in kilowatts. So I'm writing 1000 over here. Okay, 1000 P over V minus R is equals to MA. We have the speed for the first case and the acceleration 1.4. So 1000 P upon V, which is 14, minus resistance is equals to mass, which is 800, and acceleration, which is 1.4. Let's simplify this and get P. So it's going to be 1000 P minus 14R upon 14 is equals to 800 into 1.4 is 1120. And when we simplify this, we get 1000 P minus 14R is equals to 14 into 1120, which is 15680. Okay. I'm going to divide both sides with 2 to simplify this. So then I get 500 P minus 7R is equals to divided by 2, 7840. This is equation 1. This would be equation number 1. For equation 2, substitute the other set of V and A given to us. So now 1000 P upon the speed for the second equation is going to be 25 and the acceleration is 0.33. So we divide this by 25 minus resistance is equals to mass into 0.33. This will get us another equation in terms of P and R, and then we'll solve them simultaneously. Okay, so 1000 P minus 25 R upon 25. We've started by taking LCM so that we can send 25 on the other side is equals to 264. Now 1000 P minus 25 R is equals to 6600, and then divide both sides with 5. I think maybe 25 से भी divide होता है. Yeah, 25 से भी divide होता है. So we have 264 here, then minus R, and 1000 minus 25 divided by 25 is 40. This is equation 2. There's a P here as well. Now use simultaneous equations elimination method or substitution method to find P and R. I am going to use elimination method. So I'm going to write these equations again. And for the second equation, I'm going to multiply it with -7 so that this becomes plus R. So we get negative 280P, then plus 7R is equals to negative 264 into -7, 1848. Okay. Now I'm going to add these. 500 minus 280 is 210. Sorry, 220. P, then plus 0, because this gets eliminated, is equals to 7840 minus 1848 is 555992. Then divide this with 220 and we get 27.2. P is equals to 25,992 divided by 220, which is giving me 27.236, rounds to 27.2. And the unit would be watts. Sorry, kilowatts, because P is in kilowatts. Okay. Now we have to find R, so substitute this value, the unrounded value of P in either equation 1 or equation 2. I'm going to use equation 1, so 500 times 27.2363 minus 7 times R is equals to 7840. Move 7R towards the right so that it becomes positive. And 500 into answer minus 7840 is 5778.1818. Now divide this with 7 and we get 825.4545 and rounded off to 3 significant figures. It's just 825 newtons. कोई क्वेश्चन है इधर? फॉरवर्ड माइनस बैकवर्ड इज इक्वल्स टू एम ए ही किया है हमने, लेकिन अब हमारे पास टू सेट्स ऑफ साइमल्टेनियस इक्वेशन बनी थी क्योंकि इसमें टू अननोन्स थे और वेलोसिटी की और एक्सेलरेशन की उन्होंने दो डिफरेंट पॉइंट्स पे वैल्यूज दी हुई थी, तो वी गॉट टू साइमल्टेनियस इक्वेशंस। उनको जब सॉल्व किया तो हमें एक पी की वैल्यू मिल गई और एक आर।
जी ठीक है बस।
नेक्स्ट क्वेश्चन इज क्वेश्चन 15। Okay. A load of mass 160 kg is pulled vertically upward from rest at fixed point O on the ground using a winding drum. Winding drum. The load passes through a point A 20 meters above O with the speed of 1.25 meters per second. Find the motion from O to A, the gain in potential energy of the load. Okay. O से A तक, यहाँ पे कहीं ग्राउंड लेवल पे O है, ये रहा O जो मिटा हुआ, ओके, और यहाँ पे A है। सो O से A तक गेन इन काइनेटिक एनर्जी, सॉरी गेन इन पोटेंशियल एनर्जी पूछा, और क्योंकि हाइट इंक्रीज हो रही है तो ऑब्वियसली पोटेंशियल एनर्जी इंक्रीज ही हो रही है, दैट्स व्हाई दे आर सेइंग गेन एंड नॉट लॉस। सो गेन इन काइनेटिक एनर्जी का फॉर्मूला होता है mg h2 minus h1, mg brackets h2 minus h1. Basically this is short for mg h2 minus mg h1. Okay, so mass is given 160, g we know is 10, the height 2, which is the bigger height, is the height of A, this height, which is 20. So 20 minus the height at O, which is 0. So 160 into 10 into 20 gives 32,000 joules. This is the gain in, oh, why have I written kinetic energy? It's the gain in potential energy. Part 2 is the gain in kinetic energy of the load. So again, zero पे तो O पे speed 0 है और A पे speed बताई हुई है 1.25 meters per second. So that means kinetic energy भी gain हो रही है as we go from O to A. So gain in kinetic energy का formula होता है half m, the bigger speed which is the speed at A minus the smaller speed which is the speed at O. So half times 160 times speed at A is 1.25 square minus speed at O is 0. So you get this product. It is 125 joules. So going from O to A, there's a gain in both the energies. Potential energy भी increase हो रही है क्योंकि height increase हो रही है और kinetic energy भी increase हो रही है क्योंकि speed increase हो रही है. The power output of the winding drum is constant while the load is in motion. Given that the work done against the resistance to the motion from O to A is 20 kilojoules and the time taken for the load to travel from O to A is 41.7, find the power output of the winding drum. Okay. The work done against the resistance. ये given है और इससे हमें हिंट मिल रही है कि हमने फॉर्मूला यूज करना है कंजर्वेशन ऑफ एनर्जी एंड वर्क. और वो क्या फॉर्मूला होता था? वर्क डन बाय ड्राइविंग फोर्स प्लस लॉस इन एनर्जी is equals to work done by resisting force plus gain in energy. अच्छा, वर्क डन बाय ड्राइविंग फोर्स हमें नहीं पता, इनफैक्ट उसकी पावर पूछ रहे हैं, तो वर्क डन बाय ड्राइविंग फोर्स को एक्स कर लेते हैं प्लस लॉस इन एनर्जी. लुक एट काइनेटिक एनर्जी एंड लुक एट पोटेंशियल एनर्जी. इन दोनों में से कौन सी एनर्जी लॉस हो रही है? नन ऑफ दीज. दोनों में गेन है तो कोई एनर्जी लूज नहीं हो रही. सो 0 is equals to work done by resisting force. So वो क्वेश्चन में दी हुई है. It is 20,000 joules. So we write 20,000 plus गेन इन एनर्जी में दोनों लिखेंगे. पोटेंशियल एनर्जी का भी गेन हो रहा है और काइनेटिक एनर्जी का भी गेन. सो पोटेंशियल एनर्जी का गेन था 32,000 और काइनेटिक एनर्जी का गेन है 125 joules. This will give you work done by driving force, which is X. And it comes out to be 20,000 plus 32,000 plus 125. ये आ रहा है 52125. अच्छा, अब पावर पूछिए और पावर के लिए ना टाइम गिवन है. तो अगेन पावर के 2 फॉर्मूलाज होते हैं. एक होता है ड्राइविंग फोर्स इनटू स्पीड, और एक होता है वर्क डन बाय ड्राइविंग फोर्स अपॉन टाइम. So we'll use this formula because we know the work done by driving force and we're given the time. So इससे power आ जाएगी. So power is equals to 52125 over time, which is 41.7. 1250 is the answer, and the unit is going to be watts. So that's all from mechanics today. कोई question है अभी तक?
No, miss.